Okay, so this is 4.6. We're going to be graphing the rest of the trig functions. So tangent, cotangent, secant, and cosecant. We're going to start with tangent and cotangent. This is what they look like. They're kind of different looking. They've got, instead of waves, it's like squiggles. And then these are asymptotes. And we did not have asymptotes in our sine and cosine graphs, so that's something new. The general idea behind why there's asymptotes is because tangent of x is sine of x divided by cosine of x. And we know that whenever you have a 0 on the bottom of a fraction, that's undefined. So wherever cosine would equal 0, that is where we're going to have asymptotes. So remember how cosine would start up high and then it would cross through 0 and then it would go down low and then it would cross through 0 and go back up high. Cosine would cross through 0 at pi over 2 and at 3 pi over 2. That's why there's asymptotes for tangent. Similarly, for cotangent, cotangent is cosine over sine. So if sine equaled 0, then we would have a 0 in the denominator, which is undefined. So wherever sine equals 0, we're going to have asymptotes. Now, typically, we only graph one period. Well, what I have displayed here is 2 periods and a little bit more. So remember, a period is one chunk before it starts to repeat. So this squiggle up is one chunk, and then it starts to repeat, squiggling up, and then it repeats again, squiggling up. So one period would be this chunk right here. Same with cotangent. So this would be one period, here's another period, and another period. This one has 3 periods graphed. So bottom line, if we're going to graph just one period of tangent and one period of cotangent, this is what they would look like. So tangent squiggles up, cotangent squiggles down. The period for both of them is the same. This is going from negative pi over 2 to positive pi over 2. Basically like a negative half to a positive half. That's a span of 1 pi. Same thing here. This one's going from 0 to pi. That's a little easier to see that the period is pi. So the thing now is if you need to change the period, instead of 2 pi over b, now it's going to be pi over b for tangent and cotangent. So that's something that's different. Tangent, whenever I graph a tangent, I figure out what the period is, and then I go half of that distance to the right and put an asymptote, and half of the period to the left and put an asymptote. And then it's a squiggle up. As far as amplitude goes, this has an amplitude of 1. What you have to kind of imagine is going over about halfway and then up 1. And then this going over about halfway and down 1. That helps you with the period. Or I'm sorry, the amplitude. So, for example, let's say that we had y equals 3 tangent x. So I would go over halfway, but I would go up 3. And here I would go over halfway, but I would go down 3. So the only difference is that now squiggle got a little bit skinnier, I guess, taller. So that's what would happen with an amplitude change for tangent. Same thing with cotangent. So again, with tangent, whatever the period is, I go half to the right and I go half to the left and I put asymptotes there. Whereas with cotangent, the first asymptote is going to start on the y-axis, and then whatever the period is, that's where the second asymptote goes. And then halfway in between, it'll hit 0. And again, for the amplitude, if you go over about halfway between here and here, and then up 1, and about halfway between here and here, and down 1, that's about how you can figure out your amplitude. So we're just going to do a couple examples so you get the hang of it. So we're going to graph 4 tangent 3x. So again, 4 is the amplitude. This is the b value. So when you go to figure out the period, it's not going to be 2 pi over b, it's just going to be pi over b, because pi is the parent function's period for tangent. So in this case, the period will be pi over 3. So whenever I graph a tangent, I'm going to go half of the period to the right and half of the period to the left. So remember, this spans pi over 3. So what's half of a third? Well, half of a third is a sixth. So I would be going over pi over 6 to the right and negative pi over 6 to the left. That would give me a span of pi over 3. And I'm going to put the asymptotes on those tick marks. And then I'm going to have a dot in the middle at 0. And my amplitude is 4, so we need to make our tick marks on the y-axis. All right, so tangent squiggles up. So if I go about halfway and then up 4, and then here go about halfway and then down 4, and then connect that with kind of a squiggle going up. That would be one period. Okay, the next one, cotangent. The amplitude is just 1. This is the b value. So to get the period, we're going to do pi over b. So it'll be pi over 4. That would be the same thing as multiplying by the reciprocal, which would be 4 over pi. Those pi's will cancel, so the period is 4. So, for consistency, I think I'll keep the colors the same. So for cotangent, we have an asymptote on the y-axis, and then the next asymptote will be at whatever the period is. So the period is 4, that's where the other asymptote will go. Then halfway in between, which would be at 2, we'll have a dot on the x-axis, and this is going to squiggle down. The amplitude is 1. So to squiggle down, we would go about over halfway up 1 and about over halfway down 1, and then make a squiggle going down. And that would be your graph of cotangent. So just to recap, whatever the period is for tangent, I go half of that to the right and half of that to the left. And that's where the asymptotes go. And then there's going to be a squiggle up in between. For cotangent, the first asymptote would go on the y-axis, and then wherever the period is, that's where the next asymptote will go. And then halfway in between is where you're going to have your dot, and then you're going to squiggle down. So cotangent and tangent look really weird, but graphing them isn't that bad when you get the hang of where to place the asymptotes. So that's something to kind of be careful of. The next graphs we're going to look at are cosecant and secant graphs. Cosecant, the actual graph of cosecant is in red. So it's this U shape and it's this U shape. And actually there's asymptotes that aren't shown in this picture. So there would be an asymptote there and an asymptote there and another one here. So the stuff that's in red, that is the graph of cosecant. But remember, cosecant is a reciprocal of sine. So actually, this cosecant graph is based off of the blue sine graph. So there's a couple things to notice. Wherever the sine graph hits 0, that's where the asymptotes are going to go. So the sine graph hit 0 at 0, so there's an asymptote at 0. It hit the 0 at pi, so there's an asymptote at pi, and it hits 0 at 2 pi, so there's an asymptote at 2 pi. And then wherever the top of the sine bump is, that's where you're going to draw your U shape. And wherever the bottom of the sine graph is, that's where you're going to draw your U shape. And those U shapes get really close to both asymptotes, but don't touch the asymptotes. So if you can graph sine, you'll be able to turn it into cosecant. And then the same thing goes over here with the secant graph. So the secant graph is the U shapes. And again, there would be asymptotes. So there would be an asymptote here. There would be an asymptote here. And secant is based off of the cosine graph. So wherever you see cosine hitting 0, that's where the asymptotes are going to go. So cosine hits 0 at pi over 2, there's an asymptote. It hits 0 at 3 pi over 2, so there's an asymptote. And again, at the top of the cosine bump, you're going to put a U shape, and at the bottom of the cosine bump, you're going to put a U shape. So if you can graph cosine, you can turn it into secant pretty easily. So here's our first example. Cosecant is based off of the sine function. So we're going to graph the sine function first. So essentially, we're going to graph 2 sine of x plus pi over 4. So this has an amplitude of 2. The period did not change because there's nothing in front of the x, so the period is still 2 pi. So I'm going to make my 4 tick marks. The period is 2 pi, so this is a pi, this is pi over 2, and 3 pi over 2. So if I graphed sine, it would have a beginning and a middle and an end at 0. The amplitude is 2, so it would go up 2, and here it would go down 2. Now all I've done is sine with the period and the amplitude. I have not accounted for this shift. So this would be a shift to the left by pi over 4. Well, pi over 4 would be right here. Pi over 4 would be like a little in-between tick mark. So we should kind of add those in. So if going to the right, one red tick mark is pi over 4, then this would be a negative pi over 4. This would be 1/4, 2/4, so this would be 3 pi over 4. 4/4, then this would be 5 pi over 4, 6 pi over 4, which reduces, so then this would be 7 pi over 4. So I need to take all of these and I need to shift to the left by pi over 4. So this is going to move here, this one will move to here, that'll move to the left, this will move to the left, and this will move to the left. So now, here's where I'm at with the red. Okay, so all we've done so far is sine with an amplitude of 2, period of 2 pi, and a shift left of pi over 4. If I want to graph cosecant, wherever the sine graph hits 0, so right here, we're going to put an asymptote. And right here is where the sine graph hit 0, so we're going to put an asymptote. And here is where the sine graph hit 0, so we'll put an asymptote. Then at the top of the bump, that's where we're going to have a U shape. And at the bottom of the bump is where we're going to have a U shape. So the stuff that's in black is the cosecant graph. So again, the blue was just the period and the amplitude. The red was our shift to the left. And then the stuff in black is the actual final answer. Okay, let's try another one. All right, this is a secant graph, so that's going to be based off of cosine. So essentially, we're going to graph -2 cosine pi over 2x. So we're going to have a flip. We're going to have an amplitude of 2. And then this is the b value, which is going to change the period. So the period for, now remember, this is cosine, so period is 2 pi over b. So that will be 2 pi over 2. I'll move it down here. That will be the same as multiplying by the reciprocal, which would be 2 over pi. The pi's would cancel, and you would get a 4. So if we make our 4 tick marks, the period is 4. The amplitude is 2. I forgot to mark these. This would be 1, 2, 3, 4. So let's graph cosine with a flip with an amplitude of 2 and a period of 4. So cosine flipped. Cosine normally starts up high, but we're flipping it. So it's going to start low and end low. Halfway in the middle is where it would go up. And then it has to cross through the x-axis to get there. So this would be our flipped cosine graph with an amplitude of 2 and a period of 4. So now, if we're going to graph our final answer, I'll do it in red. Wherever cosine hits 0, that's where the asymptote's going to go. So here and here. And then at the top of the bump, that's where you're going to draw your U shape. So then here, down at the bottom, it'll look like that. And down here, it'll look like that. So that would be our secant graph. So just as like a little recap, anytime you're doing cosine, sine, secant, cosecant, your period is 2 pi divided by b. But if we go all the way back to the beginning with tangent or cotangent, now it's just pi over b. Because the period for a single chunk of tangent is a span of pi. And again, remember, with tangent, whatever the period is, go half of that to the right and half of that to the left. And then that's where you're going to put your asymptotes. So let me do kind of a quick little, I'm going to add a page here. Let's pretend that we were going to graph tangent, and let's pretend that the period ended up being 6. So if I'm going to graph, I would go half of 6 to the right and half of 6 to the left. So half of 6 is 3. So I'd have 3 to the right, -3 to the left. That would be where the asymptotes would go. And then we would put a dot in the middle and squiggle up. That's basically tangent. Oops. Let's say that I had tangent and the period was 9, let's say. So we're going to go half of 9 to the right and half of 9 to the left. Well, what is half of 9? Half of 9, you could just do 9 over 2, couldn't you? And then -9 over 2. Yeah, you could just leave it like that. Instead of rather than a decimal, fractions would be better. And you would put your asymptotes there. And then you would put your dot in the middle and squiggle up. Cotangent, let's do an example of cotangent. So let's say we were graphing cotangent and we found that the period was 5, let's say. So cotangent, put your first asymptote on the y-axis, and then whatever the period is, that is where the next asymptote would go. So this would be a 5 then, because that is what I said the period was. And then you would have to go halfway in between. So that would be 5 halves. That's where your dot would go, and then you would squiggle down for cotangent. Okay, so tangent, you go halfway to the right, halfway to the left, squiggle up. Cotangent, you start on the y-axis, whatever the period is, that's where your next asymptote goes. Halfway in between is where it's going to squiggle down. So you've got 4.6 homework to do. And you're going to have the little mini quiz. So do the mini quiz first, and then after you get done with that, you can start working on the homework. All right, thank you and have a good weekend.